Hello everyone, Ismail is here. Today we're going to learn about 1.3 continuity in behavior and limit. This is a very nice, easy lesson. You can find it on the pre-calculus. Okay, now let us start learn about the lesson. First, let's go through what you're expecting to learn in this lesson. We have two things. First, use limit determine the continuity of function and apply intermediate value theorem to continuous function. Then use limit to describe the end behavior of function. Okay, now let's go through the lessons to understand what the limit exactly mean. Now, as you can see, limit here means, or we can understand the limit as a wall, a value that you can get closer and closer and closer to but never achieve. So as you can see, it's similar to this guy here. So this guy here is so sad. Why he is so sad? Because he was going to cross the bridge, but he just go closer and closer and closer to the gap, but then he can't. He just know that he can jump, or he can just go through this hole. Okay, so this is in general way what is the limit. Okay, or we can say here limit are the same. You can get a number that is used, okay, closer and closer, but never that number because it does not exist. Okay, so this number does not exist, so it does not exist, so that we will write it as DNE. DNE means does not exist. Okay, so just an example, let me give you an example. So let's say I have a function f of x, okay, and f of x example x minus 4 over x minus 4. Okay, so let's say I have just random function, okay, and x minus 4. Okay, perfect. Now if I need to find my function at x equal 4, now if I need to replace x with 4, so it will be 4 minus 4 over 4 minus 4, which is equal 0 over 0. And we know that the rule in math, we can't have any number over what? 0, because we can't divide on the 0. So of course when I have 0 over 0, that means does not exist. So the value of number 4, so x, when x equal 4, the value here does not exist. So of course if I need to draw the function, so the function will be a whole open circle, okay, then complete the function. As you can see here, this whole value at number 4 does not exist. Okay, so that's the mean of the limit. So it means you are going closer to the function. Okay, you are going closer, then at the end you can't intersect, or you can just jump, you can't just go through this point, or from the left or even from the right. Okay, so from the right side, if you go closer, you will reach the same point. If you go closer from the left, if you move, you will still go the same. So how can I represent this one using limit? Okay, we know that limit from its the beginning, L-I-M-I-T-S, its limit. So we are taking only the first 3 letters, lim. Okay, so when I need to represent limit, so I have to represent it as this. So this is how can I represent the question. Lim, which is limit x approach to. Okay, what's the value that you need to test is number 4. So x, when limit x approach number 4, then for what? For f of x, or I can rewrite it as limit when x approach to 4. Now what is f of x? What is the function f of x? The function of x is this one here, right? So I can replace it with f of x. I can just write x minus 4 over x minus 4. So the answer for this one is 0 over 0, which is does not exist. So you have to replace only 4 in the x's, then you get the answer. Okay, so this is in general how we can identify or understand the limits. Okay, now let's take some types of discontinuity. Okay, now we have different type of discontinuity for the limit here. Now as you can see, we have 3 different types. The first one we call it infinite. Okay, infinite discontinuity. So what is the infinite discontinuity? Infinite discontinuity means when you have, or let's say before we start with the infinite, let's start with the removable point, because we talk example about removal. Means when you have, look to this graph, when you have a function, okay, and you have an open circle, so that means this point is not included, and you have complete the function. So as you can see from the left and from the right, there is one exact point, okay, one exact, okay, exact missing point, okay, exact missing point. So this one, we call this one removable discontinuity, okay. Now the other one is jump discontinuity. The jump discontinuity, when you have a function, so let's say I have this function, this value is included here, so this is a function, and on the same value at C I have here an open circle and another function, okay. So this this one here is a function, and this one here is different function. So as you can see, I have two different function, okay. And the point at C, if I ask you what is the value at point C, so you will tell me maybe here, okay, or maybe this one. So if I ask you what is the value of the C from the right, okay, so the value of the C from the right, because the right side of the C is here, right? So what is the function on the right side? It's up. So you can say this one here. What is the value of C from the left? So from the left means here. So the left is this one here. So this one should be the point. Okay, so we call this one jump discontinuity, which is the function is jump on a certain or one point. Now the last one here is the infinite discontinuity. So the infinite discontinuity, let's take the same point, so the same point C. So as you can see, the same point of C. So what is the value or the answer, okay, for C? If we complete a straight line, okay, like this, so as you can see, the function will be coming close and close to the y value, close and close to y value, the green one, but will never cross the C. So we call this one infinite, because the function will just move for infinite, positive infinity, and here is negative infinity for forever, okay. So as you can see here, it will be positive infinity, or it will be negative infinity, or sometimes both of them are positive infinity, okay. Why both of them are infinity? Let me give you the situation. So let's say this is y, this is x, so the function will go forever, and it will go forever at point C. So as you can see, both the function from the right and from the left is going forever to in positive infinity, or sometimes both of them are going to negative infinity. So what do you think? It will be the same. So the function will be the same thing. Both of them will go for infinite forever, okay, at the point C here, okay. So if you check the point, so this one here, so it will be both of them will be negative. Okay, I hope you understand now the different type of discontinuity. Now let's take example to let's say maintain what we understand first. Okay, now we have here something we call it continuity test. The continuity test means we have to test three things. First, we need to test the value at the point C. Number two, we need to find the limit of the value at point C if it exists. If the point at C and the limit are same or they are equal, so as you can see, limit f of x equal f of C, so the value is exists. So now if the function is continuous at f of C or limit f of C, okay, so the function is continuous, there is no discontinuity. Okay, let's apply it to the first example here. Identify a point of continuity. Okay, let's read the question. Determine whether, okay, f of x, this one here, 2x squared minus 3x minus 1 is continuous at x equal 2. So the question will give you the points, so you have to test the question on that point. Justify using continuity test. Okay, continuity test, we have three things. So the first one, we need to test, does f of 2 exist? So we have to replace x with f of 2. Why f of 2? Because he gave us 2. Okay, so now f of 2 equal 2 times 2 to the power of 2 minus 3 times 2 minus 1. So the answer should be, the answer is 7. Okay, now after we know, sorry, not 7, the answer is, I think, is 1, yeah, because this one 8, 6, negative 7, yeah, so the answer is 1. Okay, so I have a value, so still it's continuous, but we need to check this. Now let's check this limit when x approach 2. Now f of x, what is f of x? This one here, f of x is what? This function. What is f of x? 2x squared minus 3x minus 1, right? So let's write it 2x squared minus 3x minus 1. Now let's replace every x with 2. So it will be 2 to the power of 2 squared minus 3 times 2 minus 1. So what's the answer? Is this one similar to this? Yes, same. So also still equal 1. So it's continuous. So now the question is saying, does limit f of x, which is that what we test in number 2, is equal to f of 2, which is what we tested on f of 2? Yes. So it's continuous. Yes, it's continuous. So what you have to write? Yes, it's continuous. Okay, at x equal 2 from the question. Okay, so when the question is continuous, so you just mention it's continuous. You don't have to mention it's discontinuous, jump, removable, or infinite. Okay, now let's take one more example here and see the different. Let's test this. Okay, determine f of x 1 over 2x plus 1. X is equal what? Equal 1 over 2. So he need me to test using continuous test using over the point at point x equal half. Now first test, we have to find f of half. Okay, f of half is equal 1 over 2, 1 over 2 plus 1. Let's find the answer. So it will be 2 times half is 1. 1 plus 1 is 2. So the answer is equal 1 over 2. So is this one continuous? Yes, it's continuous. Okay, now let's test number 2. So limit when x approach 1 over 2, okay, at f of x. F of x is what? Is 1 over 2x, 1 over 2x plus 1. Okay, so just replace 1 over 2. So the answer still will be same thing, 1 over 2. So it's continuous. So now number 3 is number 1 and number 2 are equal. Is f of half is equal to limit, okay, when x approach to 1 over 2, 1 over 2x plus 1, are they equal? Yes, because this one is half, this one is half, so yes. So we can say yes, okay, yes, continuous, okay, can just say continuous at x equal 1 over 2, okay. So as you can see, these two questions continuous at x equal 2. Now try to solve these 3 questions by yourself, and if you need help, please let me know. Now let's take this example here. Okay, identify a point discontinuity. Determine whether each function is continuous at the given value. Justify and let's check what type of discontinuity. Okay, so as you can see here, this is a piecewise function. So I have to find the value at x equal negative 3. Okay, now x equal negative 3. Negative 3 in what function? In the first one or in the second one? So negative 3 in the second one. So now we are going to use this function because negative 3 in the second function. Now let's use it. So let's find f of negative 3. F of negative 3 is equal to minus negative 3 equal what? Is equal negative. With negatives become positive 3. So the answer will be 5. Okay, now let's find the limit, okay, when x approach to 5, okay, sorry, not x approach to 5, sorry, okay. Now let's find the limit when x approach to negative 3, okay, for the function t 2 minus x equal 2 minus negative 3 equal 5. So as you can see, this one and this one is continuous from both sides. So for sure the function is continuous at x equal negative 3. But you have to put 2 underline under but. Now if you check this question, okay, we have 2. If we have a piecewise function, we have to test also the negative 3 in the second function before I said f of negative 3 is equal limit f of x when x approaches negative 3. No, we have first to check if negative 3 in the first function is the number that I will get here is similar to the 5. If it's similar to the 5, yes, so it's continuous. If it's not similar to the 5, so that means there is a gap or there is something here, there is discontinuity. So now let's apply negative 3 in the first function. So now f of negative 3 for the first function, 3 times negative 3 minus 2 equal 3 times negative 3, negative 9. Negative 9, negative 2 is equal negative 11. Oh, so as you can see, this is negative 11 and this is 5. They are not equal. Okay, let's test limit. Okay, when x equal negative 3, 3x minus 2 is equal. So 3 times negative 3, which is negative 9. Negative 9 with negative 2 is equal still negative 11. Oh my God. So as you can see here, from the right, okay, it's not the same from the left. So the function in the blue color, when I replace it, I get 5. But when I replace the negative 3 in the first function, which is this one here, okay, I get negative 11. Oh my God, what should I do? Oh my God, this is a hard question. I don't know how to solve it. Oh, no, don't say this. Now, what you have to do, you have to make table. Why you have to make table? Because you need to know, is this table, or let's say, you have to do a table. This table will help you to find is the type of discontinuity. This table will show you if the function infinite discontinuity, or jump discontinuity, or removable discontinuity. Okay, and you know that, let's go back here to the discontinuity. Okay, let me tell you this. So if you make the table, let's make table x and y. Now this one will be the value that you need to test. If the value from the right, okay, is equal to the value from the left, so that's me, if this one 5 and this one is 5, so both of them, they are approaching one value, so we call this one removable, okay, discontinuity. Another one, if, let's make another table, x and y, okay, and when you apply the discontinuity, so from the left is any value, example, any value, let's say negative 3, okay, and from the right approaching any other value, example 0 or 5 or 6, okay. So as you can see, from the right is negative 3, from the left is 6, so they are different, right? So we call this one jump discontinuity, okay. So when they are different, jump discontinuity. When they are equal, removable. Okay, the third situation, okay, when I make the table x and y and I have in the middle my value, so if this answer on the right is always increasing, 1,000, big number, so that's mean we are approaching infinite. If it's on the left side, okay, if it's positive or negative, or let's say negative something like this, okay, so this one is negative. So as you can see, from the right is positive, from the left is negative infinite. So as you can see, so for sure it will be infinite, okay, discontinuity. Okay, I hope you can differentiate between these three types. Now, let's go back to the example that we are trying to solve now. Now, let's make the table. First, let's make the table here, x and, okay, let me give a space for me, x and y, big table. Now, in the middle, okay, in the middle of my table, I have to put the given x, which is negative 3. Now, as you can see, okay, as you can see, here the x's, okay, let me write it, on the right side, so the value on the right side is greater than negative 3, right? So which function is greater than negative 3 is the first one. X is greater than negative 3. So I'm going to use this function on the right side. Now, let me write it in the red, because I wrote it in the red in terms of the beginning. So as you can see, so this one will be 3x minus 2, because this equation we are going, the question used this equation because for the any number greater than negative 3, and the question used the other function, which is 2 minus x when x is less than negative 3, 2x. Now what you have to do, you have to make small values. So let's pick small value. What's the smaller than negative 3? It's negative 2 greater than negative 3, negative 2.999, negative 2.99, negative 2.9. Okay, now let's pick point less than negative 3, so it will be negative 3.001, okay, negative 3.01, then negative 3.1. Okay, now what you have to do, you have just to replace them in the calculator to get the answer. Okay, now let me just make it fast for you, because I don't need to use the calculator always, but I will just use it for one time. Okay, when you add the negative 2.9, so you will have to replace it. 3 times negative 2.9, always put a bracket, minus 2. So the answer for the first one is negative 8.7. Okay, now replace this one also. 3 times negative 2.99 minus 2. Okay, so the answer you will get negative 8.97. okay, now so the third one here, it will be negative 8.997. So as you can see, it was 8.7, 8.97, 8.997. So it will be, the next 8 will be 997. So as you can see, negative 8.9, negative 8.9. So we are approaching what value from the right? Negative 9, okay, or negative 8.9. okay. Now from the right side, now let's put on the right side, let's replace the first one here. So I have to replace it in this equation here. So it will be 2 minus 3.1. Don't forget to put it inside the bracket. Okay, 2 minus 3.1. So it will be 5, because negative it will be positive. So 2 plus 3.1, it will be 5.1. okay, now let's apply this. 2 minus 3.01. okay, so sorry, negative, minus here. Okay, minus 3.01. okay, so as you can see here, minus will become positive. So 2 plus 3, so it will be 5.01. okay, and if you complete it here, it will be 5.001. So as you can see, every time I'm proving 5.1, 5.01, 5.0001, so 5.0. So any number 5.0, so that's mean it's the same number, which is equal 5. Now, what do you think this type of discontinuity, when you have it from the left, is not the same from the right? So if this one not same, so we call this one jump, okay, discontinuity. Okay, discontinuity. Okay, I'm sorry, my spelling English is bad. So jump discontinuity at x equal what? X equal negative 3. Okay, so this is how we can solve the question. And to make sure that it's jump, if we go back here to the explanation that we did, so when you have two different values from the right and from the left, so we call this one jump discontinuity. Okay, now let's take one more example here. So check this example. Identify a point discontinuous. So we need to do the same thing. Okay, here the question gave me two x's. So he asked me to test at x negative 3, and he asked me to test at x equal 3. Now I will just start now with x negative 3. Let me just put a straight line. So here we are going to test x equal negative 3, and on the other side we are going to test x equal 3. So we have two tests to do. Okay, let's start with negative 3. So the three tests we have is, first thing is to find f of negative 3. So now f of negative 3 equal negative 3 plus 3 over negative 3 square minus 9. So the answer will be 0 over 0. So 0 over 0 means what? It does not exist. And because it does not exist, for sure the limit does not exist. So let's apply limit. Limit when x approach to negative 3. So negative 3, sorry. Okay, for x plus 3 over x square minus 9. So for sure it will be does not exist. So both of them are does not exist. So what I have to do, I have to make table. When you substitute the value and you get does not exist, so just make table. You don't have to do the limit. Okay, but I just did it for you. Now let's make table. So I have x, I have y. Make a long table. In the middle you should put the point, which is negative 3. Okay, and pick greater than negative 3, negative 2.999, negative 2.99, negative 2.9. Pick points less than negative 3, negative 3.001, okay, negative 3.01, then negative 3.1. Okay, now let's replace the points in the equation. So as you can see, this is not a piecewise, it's just only one function. So from the beginning to the end, all that I'm going to replace it in f of x. Okay, so now let's start replace one point by point. So this we need to check this value here. So now first let's replace negative 2.9. So it will be negative 2.9 plus 3 over negative 2.9 square minus 9. So we have to replace this one to get the answer. You will get the answer 0.16. Okay, 16 something, but we do not have to write everything. Now let's apply this one just really fast. I will not just replace it in the equation. So the answer is the answer here will be negative negative 0.1669, and here it will be negative 0.16669. So as you can see, more I'm going close to negative 3, the value is going close to what? To negative 0.16, right? So this one is the value from the right. Now what you have to do, you have to try to replace the other one on the equation. So now let's replace negative 3, negative 3.1, okay, plus 3 over negative 3.1 square plus minus, okay, minus 9. Okay, so the answer will be negative 0.16. And if we find this value also, you will find it negative 0.1669. And if we find negative 3.001, it will be negative 0.16669. Okay, so as you can see, all we close to negative 3, we close from what value? Negative 0.1616. So from the right is equal from the point of them from the left, both of them are same. So what we call this discontinuity? Yes, it's removable. Okay, removable. Okay, discontinuity. Okay, removable discontinuity. Let me write it here at what? At x. Don't forget to mention this. Don't forget to mention the point, because we have 2 points, so you have to mention the 2 points. At x equal negative 3. Now let's do x equal 3. So let's do it fast. Okay, first let's replace it in the function. F of 3 equal 3 plus 3 over 3 square minus 9. So it will be 0 over 0, sorry, not 0, 6 over 0, which is equal, does not exist. So it does not exist means I have to make table. So x and y, I don't have to write the limit because I'm 100% limit will be similar to this. So let's test 3 from the right, which is, let's get greater the 3.001, 3.01 and 3.1, and here 2.999. okay, 2.99, and here 2.9. Now let's replace the values in the equation. So let's replace the first one, 3.1 plus 3 over 3.1 square plus, or not plus, why I'm always writing plus, which is 9. So the answer will be 10. Okay, now if we replace 0. I mean in 3.01, if we replace 3.01, we will get the answer is 100. And if we replace 3.001, we will get 1000. So as you can see, the number is what? Is increasing. So increasing forever. So that's mean what? Positive infinity. Okay, now let's test the other one here, which is 2.9. Okay, so if we put 2.9 plus 3 over 2.9 square minus 9, so the answer will be negative 10, and here the 2.9 will be negative 100, and here it will be negative 1000. So as you can see, as we are approaching 3, we are decreasing, we are going down, means negative infinity. And when you have negative infinity from the left, positive infinity from the right, what type of discontinuity? Yes, it's infinite. Okay, infinite discontinuity. Okay, at what value? At x equal 3. So as you can see, this question has 2 different discontinuity. The first one is removable, the second one is infinite discontinuity. I hope you understand this. Try it now by yourself to solve this question and tell me what type of discontinuity you get. Okay, and if you need help, please text me. Now